Hey guys, this is our assignment for the week of June 1st. Two things about this. Throughout this package, there's going to be two ways presented to do everything. Just take the way that makes more sense to you and stick with that. And then the second thing is that you can use the calculator. I want you to follow the steps that it sets out, but you can use the calculator on the harder division questions. All right, so the first thing that it's talking about is front-end estimation. You'll notice that I have some things written in because I already made this video, but people kept on interrupting me and it got deleted. Anyways, it's talking about front-end estimation. So front-end estimation is where you take everything before the decimal and you just use that as your estimate. It helps you know where to place the decimal when you actually do the math. So to tell you the truth, I don't agree a ton with front-end estimation because sometimes it's really accurate. Like in this example, 13.1 plus 2.4, you just change that to 13 plus 2 and you have a front-end estimation of 15. However, in classic estimation, you would take anything above 5 in a decimal and round it up, right? You do your rounding first. So that means that if a number was 7.9, you would change that to 8 because it's a whole lot closer to 8 than it is to 7. In front-end estimation, you just take the front end. You don't actually take the back. Now, what it is good for is figuring out where to place the decimal. So, for instance, this one, 2.168 plus 0.948. In front-end estimation, it would just be 2 plus 0. I would say that it would be better to do 2 plus 1. But either way, it's either going to be, your answer is either going to be 2 or 3. And when you come to get your real answer, when you do the actual math, it's 3.116. And so all it's showing me is where to put the decimal. So whether your front-end estimation answer was 2 or 3, you know that the decimal is going to go after the 3. It's pretty straightforward. You know it's not going to be 31. It's not going to be 311. It's going to be 3. All right. So again, here you do front-end estimation to do your subtraction. So your front-end estimation would be 9 minus 0. And then you actually do the math, 973 minus 41, and you get 932. And you know that through your front-end estimation that the decimal should come after the 9 because it's 9. It's not 993 or 932. All right. Then we're getting into longer answers. So it's talking about the difference in mass. Difference is one of those magic words that tells me that this question has a subtraction. That's what the question is going to be because the word difference means the answer when you've done a subtraction question. So it says, what is the mass of these objects? I chose something that was really big, but basically you need to put any two numbers together that when you subtract them, you have a total of 0.479 kilograms. And then you got to figure out what would be that weight. So I did this backwards, right? I was like, I want to do giraffes. And I looked it up, and giraffes are about 800 kilograms. And so I thought, okay, what's a subtraction question I can do? But they're both around 800 kilograms. Okay, for this, Salvatore ran on Saturday and Sunday. First of all, add them together. So you estimate first, do your front-end estimation to add them together. And then you actually calculate it, how far he actually ran, so you do the math. And then you want to figure out how much further he ran on Sunday than Saturday. So you take Sunday, subtract Saturday, and you do that with an estimate, right? 3 minus 2. And then you actually do the math and figure out how much he actually ran more on Sunday than Saturday. Okay, this one's about a car odometer. So when they left, their car meter said 63,589 kilometers. That's how far the car had ever driven. When they came back, this is how far they had driven. So I want to find the estimate the distance. So I want to say, you know, like it was about 67,000 minus 63,000, and estimate, and then I actually want to do the math. All right, these questions are all really similar. You're going to estimate and then actually do the math. So Sylvia purchased groceries.
Terry Lynn Roberts, I have a message in the office for Terry Lynn Roberts.
You're going to estimate to find the total cost of the grocery. So 3 plus 5 plus 2 plus 1 plus 6. And then figure out what your estimate is. Then you're going to actually add them together. And then this is pretty straightforward. Difference in price of the peanut butter and fish. So you take whatever one is bigger, subtract the one that is smaller. That's the difference. Remember, the difference means this is a subtraction question. And then once I have my whole total, this one, it says Sylvia gave the clerk $20, and so then you're going to figure out how much she should receive back. All right. All right. And then when we're looking at the bottom, so Paul packages boxes of apples for an orchard. So we want to estimate the total mass. So when we estimate, we're just doing front-end estimation. So 9 plus 9 plus 8 plus 8 plus 8 plus 8. And then we're actually going to do the math and calculate it out. For these, you can use a calculator if you don't think that you can do that math. But if you are like, man, I haven't done some good addition in a while, challenge yourself, line it up, do the math. All right. Next thing. Okay, so this is multiplying decimals. It's telling you that there are two different methods. The first one is a base 10 block, which honestly, when I first looked at it, I was like, I have no idea what this is saying. And then there's the way that you just multiply whole numbers, and then you figure out your answer. So this makes more sense to me. However, in the answer key, because I wanted to actually be able to do it, I did up a bunch using the base 10 method, and I thought, actually, that's not so confusing. It actually works not so badly. Okay, so the first one is write a multiplication question for it. So basically, it tells you, that a flat, so that's one of these, represents 1. A rod, so that's a thing of 10 in a row. That represents 0.1. And then one little cube represents 0.01. So it's asking you how much this is. So it's asking you to do a multiplication. So I know that it's 1 whole plus 2 littles. So 1.2 times 1.2 is the first one. And then you're going to do this one. So you're going to tell me, there's great examples up here that demonstrate how to do it, how you would count it out. And I'm telling you already that this one here, sorry, I had a distraction there and I lost my pencil. Okay, that this first one here, question 1, is 1.2 times 1.2. You only have to do a question, you don't have to give me an answer. So that's 1 whole and 2 littles, 1 whole, 2 littles, and I'm timesing them together. Okay. For this one, use your base 10 blocks to find each product. Now, again, I've said that you can use whatever method works for you. So I've demonstrated in the answer key both ways. I'm just going to demonstrate using a classic multiplication right now. So if I'm doing a classic multiplication, I can do 26 times 13. And that we know that we start here, multiply it out. So 3 times 6 is 18, carry the 1, 3 times 2 is 6, plus 1 is 7. We have to put a 0 there as a placeholder because now we're timesing by the 10. And so that's 6 and 2. I'm going to add them all together. And then I'm going to, sorry, I didn't carry a 1. I get 330. Now, the way that I learned how to do this is that I would put my decimals in ahead of time. And however many decimals are there, that's how much I counted here. So there's 1 decimal here, and there's 1 decimal here. So then when I'm looking at my final answer, I would calculate 1, 2, because I have those together. And I know that my final answer is 3.38. So I would put that here. Now, what the instructions are showing you here is that you would, do all the math. You'd have 338, and then you would use front-end estimation, right? So you would say 2 times 1 is 2. I know that 2 is a whole lot closer to 3 than 33 or 338, so I know that my decimal is going to go there. Now, both of those methods are correct. Again, you can use a variety of different methods. This is what I'm most comfortable with, counting the decimals in and then using it for my answer, because that's concrete to me, so I understand it. But if you want to try any of the other methods, they're really clearly instructed in the answer, or sorry, in the instruction page of this. So on this page, it takes you through these two different methods. You can use whichever one you want. So the next one is 2.1 times 0.8. Doing that question, either using the base 10 blocks, using the one that I've shown you here, whatever you would like to do. And then the next one, 0.7 times 0.3. If you're confused with any of these, give me a shout. We'll go over them. All right. Multiply, use front-end estimation. So it's asking you to actually do the answer. So 63 times 7, and then use front-end estimation, which would be 6 times 0, which is 0, to figure out what the answer is. So 63 times 7, 7 times 3 is 21, carry the 2, 7 times 6 is 42, plus the 2 is 44, and we know that when we're doing this, that 4 is a whole lot closer to 0 than 441. This is the thing that I was saying I don't like about front-end estimation, is because when I'm looking at this and I'm saying, okay, if my front-end estimation told me 0, should the decimal be here, which is 0.4, or should my decimal be here, which is 4.4? Because both of them are fairly close, which is kind of why I like rounding up. So 0.7 is closer to 1, so it would be 6 times 1. So if I estimated the right way, sorry, I shouldn't say right way, my classic way, if I estimated my classic way, my answer would be 6, and then I know that the decimal is going to come after 4. All right, but that being said, you can do it the way that I said on the previous page, where it is 0.3 times 6.3 times 0.7. You get the same math here, but then you just look at how many decimals do I count in. 1, 2, put my 1, 2, and decimal still goes in the same place. No matter what I do here, I'm going to get the exact same answer, whatever method I use. All right, here again, it's telling you to do front-end estimation here, and then do the actual math to figure out where to put your decimal. All right, a rectangular room measures 2.3 by 3.2. Find the area of the room. To find area, we just times length times width. The product of two decimals is 0.24. Product, this is one of those magic math words. It means that we're doing a multiplication question. So write a multiplication question that the answer is 0.24. So if I was doing this, I might do like 0.8 times 0.3, because I know that 3 times 8 equals 24, so that equals 0.24. Then I'm going to figure out two other math questions that will also equal 0.24. All right, Chang has a part-time job as a playground leader supervising children. Her hourly wage is 9.25, and she works 17.5 hours per week. So first of all, I'm going to estimate what's 9 times 17-ish, and then I might even round that up to do 10 times 20, and then I'll actually do the calculation. So I'll do the math. 925 times 175, and then I'll figure out where to place my decimal. Using that answer, because that's how much she earns in a week, I'm going to figure out how much she earns in 5 weeks. So whatever my answer was here, I'm going to use that to figure out how much she earns in 5 weeks. All right, the next one is dividing decimals. My video is going to time out, so I'm going to pause here and do a second video.